Hello everyone, and welcome to TechnoBoss. I am MacGyver, and today we, to include me, are going to be learning some basic programming and circuitry based on the Arduino platform. The kit that I'm using is the Artist DIY kit that I found on Amazon for $83. Take note, none of this is sponsored by anybody. Okay, I wanted to learn some of this stuff, and this kit looked like it might actually fit the bill. Lesson 5, Serial Port. Overview. In this lesson, we will program the Arduino Mega 2560 to send and receive data through the serial port. The Arduino receives data from the PC, controls an LED according to the received data, and then returns the state of the LED to the PC serial port monitor. Requirements: an Arduino 2560, a USB cable. Optional requirements: if you're doing this with a board with no built-in LED, these are a lot more required. If you have a built-in LED, these are indeed optional. One LED, one 220 ohm resistor, a breadboard, and 2 jumper wires. So it's the same list from lesson 1. So if you wanted to build that circuit again or build one of the other circuits from the previous lessons, that's fine and dandy. I'm just going to use the built-in LED. Principle: serial ports. Used for communication between the Arduino board and a computer or other devices. All Arduino boards have at least one serial port, also known as a UART or USART. It communicates on digital pins 0, RX, and 1, TX, as well as with the computer via USB. Thus, if you use these functions, you cannot also use pins 0 and 1 for digital input and output. Even though 0 and 1 says RX and TX, we can still use them like pins 8, 9, 13, all the pins that we've used lately. We can use 0 and 1 the exact same unless we're using them to transmit data. You can use the Arduino's environment's built-in serial monitor to communicate with an Arduino board. Click the serial monitor button in the toolbar and select the same baud rate used in the setup function, serial.begin. To use digital pins 0 and 1 to communicate with your personal computer, you will need an additional USB to serial adapter, as they are not connected to the Mega 2560's USB to serial adapter. To use them to communicate with an external TTL serial device, connect the TX pin to your device's RX and the RX to your device's TX pin, and the ground of your Mega 2560 to your device's ground. TX transmit, RX receive, so you're transmitting from one device and you're plugging it into the receiver of the other, and vice versa. Do not connect these pins directly to a RS-232 serial port. They operate at 12 volts and can damage your Arduino board. So this is what the RS-232 port looks like, and a basic pin out of it. This is a port that you will see on like some older computers. I guess this is more of a for your reference. Don't plug into this. Key function: begin. Sets the data rate in bits per second, baud, for serial data transmission. For communicating with the computer, use one of these rates: 300, 1200, 2400, 48, 96, 144, 192, 288, 384, 576, or 115, 200. However, you can specify other rates, for example, to communicate over pins 0 and 1 with a component that requires a particular baud rate. The syntax: serial begin speed. The parameters: speed in bits per second, returns nothing. When we do the serial begin, whichever one of these speeds we're going to use, I'm guessing the 9600, where it says speed is where we're going to put the number 9600. Print prints data to the serial port as human readable ASCII text. This command can take many forms. Numbers are printed using the ASCII character for each digit. Floats are similarly printed as ASCII digits, defaulting to 2 decimal places. Bytes are sent as a single character. Characters and strings are sent as is. For example, serial print 78 will give 78. Serial print 1.23456 gives 1.23. Serial print in gives in, serial print hello world gives hello world. An optional second parameter specifies the base format to use. Permitted values are BIN, binary, or base 2, OCT, octal or base 8, DEC, decimal or base 10, and HEX, hexadecimal or base 16. For floating point numbers, this parameter specifies the number of decimal places to use. For example, 78 binary is 1001110. 78 octal is 116. 78 decimal, 78. 78 hex is 4 echo. A decimal number return. 0, all we get is everything before the decimal. 2, we get the 2 spots after the decimal, along with everything before it. And 4 gives 4 spots after the decimal. And there, of course, everything before. You can pass flash memory based strings to serial print by wrapping them with F parentheses. For example, serial print F parentheses hello world to send a single byte, use serial write. And the syntax serial.print val, serial.print val format. Okay, so value is going to be like the examples above where they're giving like 78, 1.23456, hello world, in, all that stuff. That's under val. Format specifies the number base for integral data types or the number of decimals for floating point types. Format is where we're going to put bin, oct, dec, hex, or 0, 1, 2, 3, 4, and it returns print. Will return the number of bytes written through reading that number is optional. Print ln prints data to the serial port as human readable ASCII text followed by a carriage return character, ASCII 13 or /R, and a new line character, ASCII 10 or /N. This command takes the same form as serial print. Syntax: serial println value, serial println value format. Okay, so it looks like the parameters are the same. Val is the value to print any data type like before, and format specifies the number base for integral data types or number of decimal places for floating point types. And of course then it returns, println will return the number of bytes written through reading that number is optional. A lot of the same thing before, I guess it just works under slightly different requirements. Read reads incoming serial data. Read inherits from the stream utility class. What the heck is a stream utility class? I don't actually understand this at all. We're probably going to run across this more and more later in these lessons, and then it will probably start to become clear. I'm hoping it does. Syntax: serial.read. Parameters: none. Returns the first byte of incoming serial data available, or -1 if no data is available. Yeah, this is definitely something that's going to become more clear in later lessons. I got a feeling when we start dealing with sensors, that's when this is going to come in handy. Procedure: build the circuit. Always the first thing. Since we're just going to use the onboard LED, we're actually not going to be building this circuit. If your board does not have a built-in LED, you definitely want to build this, so then you know that it's working. Because right here on the board is the built-in LED, and that's what I'm going to be using. Program. We got a program that we're going to follow. Doesn't look too hard. However, I'm seeing some stuff in here that I don't think we've gone over yet. But as long as it works, we'll get it figured out. And it's also using pin 11. I'm actually going to be using pin 13 instead when I actually start programming in. That way I'm using my built-in LED. Most Arduinos, pin 13 is their built-in LED. Check your board to see which pin it is to be sure. That way it all works right. Compile the program and upload to Arduino Mega 2560 board. Open the serial monitor and select the appropriate baud rate according to the program. Now if you send a character 1 or 0 on the serial monitor, the state of the LED will be on or off. And this is in the Arduino IDE 1.6.1. Mine is 2.1.0. Should all work the exact same. And in their little thing, they got all the code printed out here. And this looks like the serial monitor. 1 should give us LED colon on, off. 0 should give us LED colon off. This down here looks like the baud rate. It's going to be a little bit different in mine, but it'll all work the same. Through this lesson, you should have understood that the computer can send data to the Arduino Mega 2560 via the serial port and then control the state of LED. I hope you can use your head to make more interesting things based on this lesson. Well, I'm pretty sure we'll be able to, but for now, let's get to programming. So first we're going to set up our global variable. Like I said earlier, I'm going to be using pin 13, not pin 11. So let's get that started. int LED pin equals 13 for me. If you're using a different pin, then put that pin in, or if you're trying to follow this exact, well, again, pin 11. And that should be it for global variables. Next, we're going to do the setup. So first is setting our speed that we're going to be interacting with the board with. So that's going to be serial dot begin parentheses 9600 semicolon. Then pin mode, we're going to set what the pin is going to be doing. So pin mode LED pin output, all caps, semicolon. And that should be our initial setup. We have the speed that it's going to be communicating at, and we are setting pin 13 to output. Time for the loop. CHAR, I believe that's character, receive, val, semicolon, defined receive data. Next line is if, parentheses, serial dot available. That wasn't discussed earlier, so I'm hoping we're going to receive more information about that later. Maybe not in this lesson, but hopefully in another lesson. And there's always referring back to the Arduino website, because they got all this information documented there. So we're not putting anything in the parentheses, but we're doing a greater than 0, and we're not doing a semicolon, we're doing a curly bracket, and we're using the receive val that we typed in earlier for the serial read. So receive, why do I keep pressing that? Receive value equals serial dot read parentheses semicolon. Then we're going to the next line. Okay, if the received value is 1, then it's going to go into our next, it looks like our next set of curly brackets. So let's hear if, parentheses. Wait, I just noticed I spelled this receive wrong. Much better. I am so good at misspelling. There we go. Receive val. So here we're putting the statement to where if the received value is 1, no semicolon because we're doing another set of curly brackets, and if the received value is 1, it's going to execute this 2 lines of code. If it's not 1, it's going to skip over it and go to the next. If the received value is 1, then we're going to do digital write. Okay, and we're going to write to pin LED pin, which is pin 13, high, so we're going to turn it on, semicolon, and then we're also going to print to the serial monitor LED on with serial dot print ln, print line I'm guessing, parentheses, quotations, in all caps, LED colon, nope, not semicolon, colon, on, then semicolon, and we're done inside this set of curly brackets. So now we're doing if the received value equals 0, if parentheses receive val equals single quotations, no, not 9, 0, curly brackets, and this will be turning the light off. So digital right parentheses LED pin comma low semicolon, and then we're going to print to the serial monitor serial dot print ln parentheses quotations LED colon off, and then semicolon. So that's going to be sending LED off to the serial monitor, okay? Then we're going to come out of everything, give us one last line for a delay 50 semicolon. Not entirely sure what the delay is for, but it's for 50 milliseconds. Well, it won't hurt us, so why not? Let's plug in the board, load up the program, and see if we did this right. Alrighty, so like always, first step, USB cord. Okay, so we haven't gotten to the magical blue smoke just by plugging it in yet. I would be amazed if we got it now. So then we're going to select the board, COM port 14. We're going to verify the code. Okay. Ooh, hey, we're getting some different numbers here. I guess we finally started writing some decent sized code. Okay. Upload. Okay. Uploading done. Serial monitor, which is this one right up here. Okay. Let's see here. Message. Enter to send message to Arduino Mega or Mega 2560 on COM port 14. Okay. New line. Baud rate is 9600. Okay. So if we press 1, so right over here, we're going to start seeing some blinking, because let's hit enter, and this light on the end should turn on. Okay. That was quick. Well, that's on, and on the serial monitor, it says on. So if we do 0, send, that is quick. That is a single flash, and then it does it. So I wonder what would happen if we just say 2. Will this thing still compile? It says it did. So let's just say 1 again, and it turns on. Okay, send 0, off. What about 2? Nothing happens. Okay, let's just go to a bigger number. Upload. So 5 turns on. 1, nothing, no change, 0, okay. 1, nothing. Okay, I must have entered something wrong then. Okay, go back to 5, turns on. Okay. 0, off. Okay, so if that's 5, oh, let's go ahead and say 42. Meaning of life is to turn off. Verify. Upload. So now 1 should do nothing. Does nothing. Good. 5 should turn on, and it does. 0 should do nothing, and it does. 42 should turn off, and it didn't. Okay, let's reduce it down to single digits. Let's say 9. Okay. Upload. 9. Does it turn? Oh, it already turned off. Okay, let's turn it back on with 5. Then 9 turns off. Okay, so we're stuck to single digits. And since this seems to be printing whatever we want, I'm feeling a little childish. So we're going to say fart. And smell. Yes, I'm feeling this childish and this immature right now. Hey, if you can't have fun, what's the point? So, 5. Oh, wait, hold on. I need to upload. There we go. Uploading done. So, 5. Fart. 9. Smell. Okay, we can have a little bit of fun with this. Thank you for joining me in this lesson. If you like what you see or found this video helpful, please like and subscribe. Click the bell icon if you would like to be notified of new videos when they come out. I can do this, and so can you. Until next time, good luck, have fun, and stay curious.